exam. And just be clear, they don't tell you ahead of time arriving and departing. Oh, which, by the way, I was thinking about this the other day. So let's check it out. It says people arrive at a gym at a rate modeled by the function r of t is equal to 3e to the x sine of x. We're going to change this. I don't like it real well right now. We're going to go r of t. Look at that. I even messed up the variables. Is equal to, we'll go 3e to the t squared sine of t. Let's do that. It's measured people per hour, and t is measured in hours. People also leave the gym at a constant rate of 3.2 people per hour. There are 50 people at the gym at time 0. Where is this taking place? At a gym. Does it make sense that people are arriving and people are departing? We are given the rate at which people arrive and the rate at which people leave. Can somebody tell me approximately how many people will leave the gym over the course of 10 hours? 32 people. Everybody see that? Okay. Now, it's not that easy when you're given this function to just identify, but we can do it. It says how many people arrive at the gym during the first 4 hours. The way that we figure amounts and accumulation is the same way we did it when we did distance and when we did accumulating snow. We do an integral. The integral of the rate from 0 to 4. So we're going to take out our calculator. This one would be an absolute must calculator type problem. I've got 3e. E is on the natural log button right there. And I'm going to grab x squared, and I'm going to grab sine of x. And please note that in this situation, as you're using sine, make sure you're always working in radians on the AP exam. So I have to switch back and forth to my other classes sometimes. And what do I press to calculate that? Second calculate number 7. My calculator is having a little bit of problem because my window's out of whack. We'll try again. Window, I'll go zoom 6. Get a little bit better of a viewing window. There we have it right there. Okay. So I second calculate and I do 7 and I go from 0 to 4. Something ain't right. Did you guys get the same piece?
Yeah, 145.
So my apologies, I'm just a little bit off here. That's not the graph that I came up with earlier, but we're just going to roll with it and carry through the problem. It'll still work out. So we get, what do we get? 145.4367. Okay, something like that. So that's the number of people that arrive over the course of the first 4 hours. Okay, 4378. Now, how many people leave during the first 4 hours? How do you get that? There's 3.2 people leaving per hour. So if there's 4 hours, we got 12 times that, right? Watch how this works as an integral. The integral of the rate, which is 3.2 from 0 to 4 dt. Can somebody tell me what the antiderivative of 3.2 is? 3.2x or t. And I evaluate it at 4 and at 0. And you get, as you said, 12.8 people. Is everybody okay with that? So question C says, to the nearest person, how many people are there in the gym at time equals 2? How would I think about how many people there are at the gym? Yeah. I would say that the 3.2 times 4, as long as you show that, they'll give you the credit. They really do like the integral setup. They really do. for sure, without a doubt, for the first one, they want to see the integral setup. If on the AP exam, if you just write this down, they will dock a point off for not showing your integral setup with the bounds. So they want you to show your work. Yep, that's part of it. To the nearest person, how many people are in the gym at time equals 2? So I've got people arriving and people departing. And I start with how many people? Yeah, exactly. Wouldn't you say it's the number of people that you have at the beginning? So how many people do we have at the beginning? 50. And then we're going to have to add the number of people that arrive, and then we're going to have to subtract the number of people that depart. So in other words, in order to figure that out, and again it's at time equals 2, of 50 plus the way we do arrival is 0 to 2 of r of t dt. And for departing, we do the integral from 0 to 2 of 3.2 t dt. So this shouldn't be any big deal. I'll just do 50. Whoops, 3.2, excuse me, no t. Yep. 3.2 dt. So I have 50, and I'm going to add to that this guy. And what is it that I'll subtract? What does the integral from 0 to 2 of 3.2 dt look like? 6.4. So it looks like 6.4 people have left, but I got to add the people that arrived. So we go here. I turn it on. Go second calculate, number 7, 0 to 2. Looks like 43.5 people arrive. So they'll be specific what they want. They'll say maybe the nearest person, but like in most situations, they want you to carry it out to the thousandth, 3 decimal places. And so I take the 50 and I add that to the 43.522 and I subtract off 6.4. And I get 87.122 people.
So to the nearest, it says to the nearest person, so would we say 87?
87 people then, yep. Trying to think about what like 0.12 of a person looks like. You know, is that like an arm?
Probably like
A forearm? Yeah.
I'd say it's like
Your
your shin.
shin?
Well, would it start at the top?
Yeah.
Maybe it's just your head.
Yeah.
Yeah, the jaw. Your head weighs like 10 pounds, right?
Yeah, human head weighs 8 pounds, so it's a great statement from the movie Jerry Maguire, if anybody's seen it. Anybody Jerry Maguire?
No.
Classic. Check it out. Classic movie. All right, during the first 4 hours, when is the attendance at the gym increasing? Tell me something about people arriving and people departing. How am I going to know if it's going up? Thinking about arriving and departing. If the rate at which people are arriving is greater than the rate of the people departing, then the attendance is increasing, right? So let's look at that. When is R of t, the rate at which they're arriving, when is that greater than what? 3.2. Now, I can make that a really easy equation to solve. R of t minus 3.2 greater than 0. Oh, look at that. Do I have R of t plugged into my calculator? I sure do. I go into y equals, and I go minus 3.2. So I'm going to look for where that thing is greater than 0, above the x-axis, right? And it looks like from 0 to 4, it almost looks like it's always above the x-axis, doesn't it? except for maybe like right there, right? Like right at that beginning. So I'm going to zoom in as a box. I'm going to try to find that spot right there, see what's going on. Oh, so it's definitely below the x-axis there, right? So that means that there's more people leaving than there are arriving right away. And then here, there's people that are arriving more than they're departing. So how am I going to find that spot? So I can calculate 0. Enter. And you guys are getting better at these problems. And I enter on guess, and I get time equals 0.405. 0.405, that's the time at which it changes. So the question is, when is the attendance increasing from 0.405 to 4? Yep. I'm not giving really any indication that they make a big deal about brackets or parentheses on the AP exam. Is the rate at which people are arriving at the gym increasing or decreasing at time equals 3? Is the rate at which people are arriving at the gym increasing or decreasing at time equals 3? Have a 20-second conversation with the people next to you about the words increasing and decreasing and what that means about F and F prime. Go ahead, talk. Okay, what did you come up with? I heard a couple people say it, and they said it correctly. Increasing means that the slope is positive, or the derivative is positive. Agreed? So we're wondering, is the rate at which people arrive increasing or decreasing? So we are going to look at the rate function. I'll zoom standard again. And if we're wondering if it's increasing or decreasing at time equals 3. So we are going to type in second calculate to figure out the derivative. Which one do we choose? 6. And we check number 3. Do you get a positive or negative value? Negative. So without a doubt, the rate is decreasing. We still have a lot of people coming to the gym, but at a much less slower rate. So R prime of 3 was equal to negative 86 or whatever, so decreasing. Just showing that's negative is going to be enough in that situation. During the first 4 hours, when is the attendance at the gym at a maximum? When is the attendance at a gym at a maximum? Well, let's just think about our graph originally right away that we talked about in this situation. I want to go to my Zoom. This is the rate function again, okay, that we have right here. But we said that the number of people, or the attendance, we said was equal to 50 plus the arrival minus the departure, right? So if we want to know the attendance, it's 50 plus the arrival plus the departure. It says, when is the attendance at a maximum? A maximum occurs when? At the top, when the first derivative changes from positive to negative. So look for where attendance prime changes from positive to negative. Remember, we have 50 plus the arrival is the integral from 0 to whatever, 0 to t of r of t dt. And the departure is the integral from 0 to t of just 3.2 dt. So we have to take this derivative. It looks bad, but it's no big deal. What's the derivative of 50? 0. Anybody remember when you take the derivative of this thing? Do you remember what happens? The integral goes away and the dt goes away, leaving you with, yep, the function. And if I take the derivative of this, what goes away? Everything except for 3.2. So that is the derivative. I'm going to look to see if that changes from positive to negative. I'll go to my window. I've got my minus 3.2. I look at my graph. Does that change from positive to negative? Changes right there, right? Is that before or after 4? Let's find out. Second calculate, 0. That happens at 3.135. At time equals 3.135, that's when it has a maximum. So if I actually want to figure out the number of people, I have 50 plus the integral from 0 to what time? No. 3.135. Minus the integral from 0 to 3.135, 3.2 dt. Does everybody see how I have these subtracted as two different integrals? You could just write it as one integral subtracted as well, which is what I have in my calculator. So we will just do second calculate. Number 7 from 0 to 3.135, and we should get a bunch of area there. Is that my answer? No. Add 50 to it. I make that mistake. I go through the whole problem. I get it right, and I forget to add 50. I get a point wrong. I get so mad when I do that. I remember one time I got a 53 out of 54. I got everything right. I've never aced the free response altogether perfectly. I made that mistake. I forgot to add the stupid 50. 50. Who cares about 50? We're at 85.11 people, so that's it. There we have. I've never got 100% multiple choice. I've gotten one wrong many times. Last one. Here we go. Consider the function f. You have a graph and then also this thing. This is a wild card problem. We never know if we're going to get this kind of problem or not. Oh my gosh, it says use the function above to determine the following along with this g of x. It says h of x is equal to f of g of x. I want to find the derivative. You've done it before. Does anybody remember how I find the derivative of something like that? It's the chain rule. What's the inside function? G of x. So g prime, the derivative of the inside, times the derivative of the outside. Thank you. I like your voice inflection. With the inside left alone, right? So I want to determine that. So I do g prime of 2 times f prime of g of 2. How do I figure out that derivative? Good, chain rule. U to the 10th, 1 minus x. Derivative of 1 minus x. Negative 1. Derivative of u to the 10th. 10 u to the 9th. So I get negative 10 times 1 minus x to the 9th. What do I plug into that thing? I plug in 2. What's 1 minus 2? Negative 1 to the 9th. Negative 1. Negative 1 times negative 10? 10. Cool. So it looks like we've got 10 right there, times. Now I need g of 2. Where do I plug 2 in? The top one. What's 1 minus 2? Negative 1 to the 10th? 1. Now I have to do f prime of 1. When I look at the graph, what is the derivative at 1? Negative 2. The slope is negative 2. Very good. So times negative 2, so we get negative 20. It says let k of x equal 5x squared times f of x. Find k prime. If I want to find this derivative, what rule do I have to use there? The product rule. K prime of x is equal to, what will the first part of my product rule be? 10x times f of x plus f prime of x times 5x squared. Cool. So if they ask you find, say, f prime of 3, you would just plug in 3 and do it. Looks like a complicated problem, but not too bad, is it? Uh-oh. Letter C, let q equal natural log of f of x. You see natural log, you start to shut down. But you remember the derivative of natural log is? Oh, isn't that great? So write the equation for line tangent. Oh, another one of those. What do we need to write an equation for line tangent? What two things do we need? Slope and a point. Good. I know the x value for the point, don't I? 1. Now I got to figure out the y value. So I plug in 1. I have the natural log of f of 1. What is f of 1? 1. What's the natural log of 1? 0. Okay, in order to find slope, I have to take the derivative. So q prime of x. How would you find the derivative of natural log of f of x? Close. Not product, but chain. What goes on the outside is the natural log of u. What goes on the inside? F of x. What's the derivative of f of x? F prime of x. What's the derivative of natural log of u? 1 over u. Because it's not natural log times f of x, it's natural log of f of x. See the difference? You multiply these together and drop that in, and you get f prime of x over f of x. That's going to give us our slope. So what number do I plug in? I plug in 1. We already decided that f of 1 was 1. What is f prime of 1? Negative 2. Very good. When you write your equation for your line, you can write it like this. Y minus y1 is equal to m times x minus x1. You don't need to put it perfectly in a slope-intercept form, unless it would ask for that, which I haven't seen that. And so you end up with y minus 0, which is y, is equal to negative 2 times x minus 1. F prime of 1, we're going to look at the slope at 1. Slope is negative 2. Almost done. These three, let r of x equal this guy. Determine r of 5. That means you're looking for the integral from 5 to negative 3 of f of t dt. Isn't that just a fancy way of saying area? Yeah. I want you right now to see if you could come up with the area from negative 3, which is right there, to positive 5, which is right here. Go ahead, talk amongst yourselves, see if you can calculate that area. Approximate it to the best of your ability. Go. What did you get?
40.
40?
I got like
What's that? Yeah, very good. Positive up top, negative on the bottom. Okay, approximately negative 1/2 would be right. Doesn't it look like the areas basically offset each other? I mean, they're very close. If you were asked to calculate that area, you actually want to break it up into triangles, so on and so forth.
Good afternoon, Sam. Just want to remind you to go over the severe weather information students.
Okay, last part, we're almost done. It now says, okay, so we said that this was like negative 1/2. Look what it says here. This is such a cool problem because it looks so super complicated, super easy. It says determine r prime of 3. If you take the derivative of that thing, what happens? This goes away, right? You're left with the function. So in order to figure out r prime of 3, just look the function at 3. What's the height of the function at 3? -3? Does r have a relative maximum over the interval? A relative maximum happens when r prime changes from positive to negative. We just said it. What is the derivative of r? What's the derivative of this integral function? Simply the function. Does the function ever change from positive to negative? At what value? And furthermore, not only does it change value there, but if you think about it, if r is the area function, wouldn't it agree with everybody that we get to a maximum area there, and then we start to lose area after that? And that's what you're thinking about. Excellent job. You've covered so many important points. We've taken you through it all. It's been